Thank you very much for the introduction. So today I'm going to talk about capability-based cost estimation and basically having a discussion with you all about a potentially new way of estimating for software. So before we get into that, I'm going to provide some background into capability-based planning based on a literature review that I have completed recently. And the purpose of that is to set up what does capability-based planning mean? What are some important definitions that are with that? And now understanding what capability-based planning is and how that relates to software, and how can we now estimate software costs? All right, so getting into the literature review. So based on the literature review, I found that there were two major industries or fields that have used the term capability-based planning. And I would say first it was used in the business or commercial industry sector, where they use this term to identify success criteria and then go about looking at how they can achieve it. And then recently, not overly recently, but recently, many governments or countries have been using capability-based planning as far as identifying what kinds of needs and capabilities their government and military forces need to have. And this was a way of replacing the traditional threat-based planning. And so what I'm going to do in this summary of the literature review I did is to consolidate the definitions that come from both of these domains to get a more complete overall view of what capability-based planning is. All right, so first, what are capabilities? How do we define what capabilities are? I found in the literature that there were four major categories of definitions of what capabilities are. The first two are related, and both of them have this concept of looking at what you can do or what you want to do at the highest level of perspective or view possible. So the first one's high-level objectives. Basically, what is it that you want to do, but you want to make these requirements or these descriptions as high level as possible. You don't want to get down into defining the exact features or functions or requirements that would make those. The next one's operational outcomes. So you can see how that's related to objectives, except now we're looking at it as far as what are general outcomes that we want. So we're not looking at specific functionalities or capabilities, but what are the required or desired outcomes? The next one I found was mostly prevalent in the commercial industry or business sector, and that was activities and processes. And so organizations and companies would look at what their current activities and processes were so that they could potentially make improvements to those to then achieve their high-level objectives or outcomes. And this last definition I think is a little different from the other three, because instead of looking at what it is that we can accomplish, it's looking at whether you have the ability to achieve an outcome. All right, so now that we have described capabilities, you can see how we have tried, and by we I mean the literature and the business and government sectors, have tried to define capabilities in very broad terms. And so similarly, capability-based planning is also defined in very broad terms. And I found that there were three different types of perspectives, and you can almost look at it as a hierarchical, you're going from cross-organizational perspective to just a single organization. And then as we get into the details as far as how we can essentially support and apply capability-based planning. So in the cross-organizational, and this is primarily prevalent to government or military forces type of applications, where we're not just looking at what one organization can do, but we're having to look at what all different kinds of organizations, agencies, military forces, what they can all do together, and what are the types of capabilities we want to have as a government, all together across all of these. And then in the more potentially business or industry sector, you have organizational perspective where they're looking at what they can do and provide to deliver strategic success. And now going into the lowest level is how do we actually implement or support this type of planning? And that is the use of scenarios. And that's just to describe what are the potential future case scenarios that we want to be able to, respond to or be successful in. And so those can then break down into case studies or use cases. And again, even here, we don't want to get down into the detailed requirements. That is meant to be done at a later time. Okay, so what are some of the benefits and challenges of using a capability-based planning? Well, the benefit is really that now if we look at things at this very broad, high-level view, we have really allowed ourselves to open up the type of solutions that we can consider. And I think the governments have especially been looking at it in this way. With the threat-based planning, you're looking at what are the specific equipments that I need. Well, now instead of just looking at specific equipment, you can say, well, we want to be able to do this particular capability, and this is going to take collaboration or integration of two different types of equipment or a few different agencies so they can all work together. And so that's one of the major benefits. It also allows for innovation because, like I said up until now, we're not defining any particular solutions or requirements yet. And so now we can consider a very broad and multiple type of solutions before we kind of select on which one we think is the best one and most cost effective. So some of the challenges that go in hand with this, however, is one of the things we must account for in capability-based planning, especially because we want it to be very broad, high-level view, something that can look into the future and prepare us for the future, is accounting for uncertainty. And that is a very real part of this planning. And of course, because uncertainty is essentially unknowns, it's very hard to try to account for that. So that is a challenge. It's not a defect of this planning phase or of this planning structure. It's a part of it. Another thing is to account for the fiscal constraints or trying to determine what your cost-effective solutions are, coming up with estimates. So each of your solutions can be very different from one another, account for or be using different pieces of agencies and their equipment and their capabilities, and then looking at, are we having to develop new capabilities or reuse or fix or enhance existing ones? And so trying to estimate for each of these different solutions and now comparing them to figure out which one is more cost effective or not is of course going to be a challenge for those of us that are in estimation. We know it's a challenge anyway. All right. Before I get into estimation more, which is really the second part of this presentation, I'm just going to talk a little bit more about CBP, capability-based planning. And so what are some of the requirements or steps that were required to get this successfully? The first one, and I would say the one that had the most definitions or descriptions, were collaborative strategies. So again, remember, we're looking at how we can look at the highest level, most broad view. And so that requires a lot of involvement and stakeholders from different sectors, agencies, systems engineers, so that we can support that high level broad view. The next thing is to identify the desired level of capability. So when we were talking about capability planning and how that's at different levels, so it could be cross-organizational, organizational, it goes down into the activities and processes as needed. And so you have to identify which level of these types of capabilities do we really need to look at and improve to meet our objectives and outcomes. We talked about scenarios and how we also want to be able to plan for and prepare for the future. And so one of the ways we do that is by using both broad and specific scenarios. We need broad scenarios that can account for all of the different possibilities of future happenings, but we also need it to be specific so that we can identify whether our existing capabilities can address them sufficiently, and if we're proposing new capabilities, how well would those address those future scenarios. Estimates, so to be able to determine whether you're using or going forth with the most effective solution, we need to be able to estimate those solutions. And since we are doing a lot of collaborating with different types of stakeholders, we need a common framework so that we can all be on the same page. All right, and finally, these are just a few of the measures that people have identified most effective for CBP, either in evaluating your current capabilities so that you can identify capability gaps, as well as when you're actually implementing them, measuring how well they are meeting the requirements and needs for your capability gaps. All right, so with that, we are now moving into the second part of the presentation, which is to talk about methods or ideas of how we can now estimate for software within this capability-based planning structure or paradigm. Okay. Just in case, I know I talked about why estimates are important in the capability-based planning paradigm, and that's because we need to be able to identify which possible solutions are cost-effective. But of course, in the more real sense, in something that we hit, especially in government and acquisition kind of sectors, is it's important to have a budget to figure out if what you want to do is feasible and if it's something that can be afforded. And I would say that this holds in the business and industry sector as well. You want to be able to see whether you're going to get return on investment, ROI. And so for all these things, having an estimate is important. Now, I think in the software world, we have this understanding that requirements can't be defined fully and in great detail upfront, that they change over time. And that's especially because software is so soft, right? Like it's not like hardware where once you've made a decision and you can see how it would fit into your physical world, that's it, and you can basically go with it. You might have some minor changes as you go, but for the most part, it doesn't change much. Software, however, is a whole other thing. And now we're seeing that, generally speaking, this whole world and a lot of the capabilities that we need to be able to account for works that way because of technology changes and how quick they are. And this is why Agile, had caused such an uproar in software engineering, because we had this concept of going back and allowing for changes in those requirements. Well, traditionally, and even now, many people still use this concept and idea that they have these requirements and that based on these requirements, they estimate their software size in terms of source lines of code or SLOC. And we have a lot of cost models that are based on SLOC. Now, if you don't have your detailed requirements and to estimate SLOC, that has to go into, what is it that we have to develop and how many lines of code do we think that's going to take? Do we have any existing code that we can use? And how much of that are we actually able to use, and how much of it do we have to modify and adjust for our new usage? And that's how you get to this slot estimate. Well, if we don't even know what the low-level requirements are, we can't really do that effectively. So what we need for software is a whole new method of sizing and estimating our software that's based on those high-level capabilities. Okay, I'm going to skip this because I think in this particular audience, we all know the trouble with SLOC. And I mean, one of the main ones that I see is that as you're learning about what you have to develop, your SLOC estimates are going to change. Now, for measurement and tracking progress and for management, we would like for the SLOC to be one set number and that's it, right? Because then you can track to it and track your progress accurately as far as how complete or not complete you are. But SLOC estimates are not very accurate early on, and they need to be changed as you get more information. And so this creates this conflict between management, tracking, development, learning, and actually updating your size estimate based on what you learn. All right, so I am proposing or suggesting a new way of estimating and sizing software. And essentially what I'm saying is what we need to do is create these capability clusters or groups that are based on similar types of functions and complexity of the software that's being built. And that we now look at these as individual groups. And very, very early in the life cycle, and I especially say this for the US government life cycle, even before developers and contractors start to look at software requirements and determine, what the size is going to be, the government doesn't really have, the processes to do that. So this would be a way for them to get effort ranges based on high-level software capabilities and come up with a rough order of magnitude estimate based just on those high-level definitions of capabilities. So we would create these groups that define software in similar terms, and then we get effort ranges for each of these groups. And that's how we would build our initial estimate. Now, of course, as we go through the life cycle, and actually I have a slide later, we can always refine our estimates. And so I'll go over that in a little bit. But let me just give examples of what kinds of groups or clusters of capabilities am I thinking of, or what does that mean for software? So here are just two possible examples. One's the GPS navigation, one's compilers and parsers. For any of us that might have some understanding of software development, with GPS navigation, you know that there are three main things that we need to do. We need to figure out where we are. We need to figure out where we want to go. But the most important part, the algorithms, is figuring out how to get from where we are to where we want to go. And that's going to take some math. It's going to take some algorithms. For example, travelers' algorithms to figure out how to get there in the most efficient way. Now compare that to writing code as a compiler or parser. Now we're scanning text and our code, and we're either looking for patterns or we're looking for pre-specified patterns. And so one is not necessarily more complex than the other, but the type of software that you have to build are very different from one another. But for software that's doing GPS navigation, even if it's on different devices, the complexity and the basic type of algorithms that need to be developed will be essentially the same. And so this is where program managers or government officials can say, okay, yes, we need to do some GPS navigation and we might need to do some parsing in our code. And now they're able to develop at least a rough order magnitude of estimate for requirements at this high level, capability-based planning level of planning. Okay, so how might I propose to do this? Um, the idea is to look at the ice bag development and enhancement data. Paula was talking about this data a little bit ago and how there's an update to it. And so for those of you who have looked at this data set, you know that they have descriptive variables for each of their projects, and then of course, effort and cost or schedule related type of variables. And so the idea is to look at the descriptive variables and see if we might be able to find patterns to kind of group similar types of projects to one another. And once we're able to identify the groups and how they're similar to each other, we can then grab the effort hours for each of those groups to create our effort ranges for each group. And that would be the base for our initial estimates. Okay, so before I go into the text here, I wanted you to look at this. This is a recreation of the cone of uncertainty, and many of you are probably familiar with this. And so you know that this is the beginning of the life cycle, and as we move right, we are getting to the end of the life cycle. And so I'm talking about making estimates here in the very beginning phases. This would be a very rough estimate based on high level requirements or understanding of what we need to develop. And once we define what our capability group is, I don't expect for that to change over the life cycle. And so what happens is as we move into the life cycle, as we learn, while our capability groups don't change, if we add in new capabilities or remove capabilities, now compared to SLOC, we can see how much of our cost variation came from one, just understanding what we were doing within our capability. So that becomes the learning, the variance due to learning. But then two, now we can see the true cost growth or scope growth or changes over the life cycle. Because if new capabilities are being added, that's going to be scope growth. If capabilities are removed, that's going to be a scope change, right? Removal. And so now we can better and more accurately look at the change in our scope as we go along. Now, the cost variation is of course still going to be wide at the beginning of the life cycle, and that will also become more and more narrow as we go along. And we can, after we get through this first initial phase, as we start to get the requirements and understand what the architecture is, we can use our other software size metrics, for example, function points, to be able to help improve our cost estimates. And so that is the idea that I'm putting out there and the kind of benefits that I see that would come along with this type of estimating method. And so with that, I will hand it over to you all for any questions or suggestions or comments you might have.
Thank you, Anandi. We don't have any questions yet, but if there are some that pop up, here we go. We've got one from Kuprananda. Are the CDP estimates required to be calibrated against other estimates later in the project and with the actuals at end?
Okay, I might not be fully understanding your question, but the thought process would be that the capabilities that we define and the groups for software, this would be a way to be able to break up our software into smaller pieces and then to also formulate a baseline that we can track progress and metrics and change the estimates as we go along in time. So the idea would be you first have your effort range, and that would come from actual data so that we have something that's evidence and data based. But then as you move along and you use your size metrics or your other estimating methods, you could use them as is, or you can also kind of group your existing data based on these capability types. So my PhD dissertation, which I don't talk about here at all, one of the things I did was I looked at function points and it compared IFPUG and cosmic function points. And I found that each one behaved differently in different types of software groups. So like IFPUG performed better in one type, cosmic performed better in another. And so now with that kind of information and with these groups and using that to kind of create groups in your data set, you could actually now make your estimates even better because now you're having similar types of projects and using, for example, your function points for similar types of projects, and that will give you a more accurate result. So in a way, yes, but hopefully I understood your question correctly.